So y'all go ahead and do the factoring and the math knowledge question, pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for this factoring, you're going to have to start by doing a remove, replace, reduce. So you're going to have x squared plus 9x plus 8. And then when you factor, make sure to plug back in that 2 that you removed. So we're going to have plus 8 and plus 1. The first one will divide by 2, and then the second one won't. So we'll have x plus 4 times 2x plus 1. For the math knowledge question, you're basically just going to plug in the 4 for your x and then plus minus 1 for the y. So we have 3 times 2 to the third. You have to deal with your exponent before you multiply it by 3. So 2 to the third is 8, and then 3 times 8 would give you 24. So your answer would be D there. Okay, so we are looking at lesson 74 today. We're looking at Cramer's rule. And this is going to be another way that you can solve a 2x2 equation system. It's where you have 2 equations with 2 unknowns. I realize that you know how to solve these types of systems of equations already, but the reason we're going to learn Cramer's rule, it can be applied to equations where you have 4, 3, 7 variables and then the same number of equations. So we're going to start with basic ones that are pretty straightforward, and then you could extrapolate it into more complex systems of equations. But hopefully you'll understand his rule after this lesson. So we started by doing this a couple weeks ago. We had abstract variables. We have abstract coefficients instead of actual numbers. We have variables instead of our numbers in front of our x's and y's. And we would simplify them to get something like this for our x and our y. Do y'all remember doing that? Hopefully so. I want y'all to write this equation down, those 2 equations, and then write your x equals and your y equals. Okay, so using elimination, we can get to those 2 bottom x and y values. So the reason I wanted you to write that down, your x is found using these 2 matrices. We had ED minus BF over AD minus BC, and the way you got that was to do E times D minus B times F. And then for your denominator, A times D minus B times C. And then the denominator on the y is the same thing. And then you have A times F minus C times E. So in your matrices, the way that you're going to figure out where your A, B, C, D, E, and F go, the elements of the determinants in the denominators are the coefficients of your x and y in your given equation. So the elements that go in the denominator for your determinant, those are the coefficients of your x and y. And then the ones in the numerator, that matrix is called your coefficient matrix, because that's the coefficient of your x's and your y's. Okay? For the numerator, the constants replace the coefficients of x whenever you solve for x. So whenever you're solving for x, those coefficients are going to be replaced by your constants in your equation. And the constants are going to replace the coefficients of the y when you solve for your y value. So we're about to do an example to help you see what that actually means. We're going to use Cramer's rule to solve. Now this one wants us to solve for both x and y. So to solve for x, we're going to have 2 matrices. The denominator is just going to be these numbers here. And you do have to look at whether they are positive or negative. So we're going to have 3, 4, 2, and negative 3. They're going to be written in the exact same order that they are in the problem. So 3, 4, 2, and negative 3. Now on this one, we are solving for x. So instead of using this 3 and 4 here, we're going to use the negative 1 and the 10. So negative 1, 10, and then the 2 and the negative 3 are still the same. The reason we replaced the 3 and the 4, those are the coefficients that are in front of your x, and we're solving for x. So now we're going to solve our matrices. So negative 1 times negative 3 is 3, and then minus 10 times 2, 20. In our denominator, 3 times negative 3, negative 9, minus 4 times 2, 8. So I have negative 17 over negative 17, so my x equals 1. Okay, now we want to do the same concept for our y. So again, we're going to have two matrices. For the denominator, it's just going to be these numbers here. And it's going to be the same matrix as what you had for the x. So 3, 4, 2, and negative 3. Now on the numerator part, instead of the 2 and negative 3, we're going to use the negative 1 and 10. Because now we're solving for y. So the coefficients for the x, the 3 and the 4 stay the same. And then instead of our 2, we're going to put a negative 1. And instead of the negative 3, we put a 10. And so now we solve this matrix. So that would be 3 times 10, 30, minus the negative 4. And then we have negative 9 minus 8. So 30 plus 4 is 34 over negative 17, which equals negative 2. So our y value is equal to negative 2. So that's how you would use Cramer's rule to solve. Now, a lot of times they're only going to make you solve for one variable. They're not going to make you solve for both, but that's how it would work. Okay, so let's look at this one. Use Cramer's rule to solve. So we've got to solve for both of our variables. So we're going to start with our x. And the denominator is going to be 5, 2, negative 3, and negative 7. And the numerator, instead of the 5 and the 2, we're going to put 1 and negative 17. And we're going to have negative 3 and negative 7. So when you multiply, you have 7 minus a 51, and then negative 35 minus negative 6. Okay? So 7 minus 51 is going to give you negative 44. And then negative 35 plus 6 is going to give you negative 29. And so, I think I did something wrong. This should be a negative right here, negative 7. That's why. So negative 7 minus 51 is going to be negative 58. I'm sorry. And so if you divide those by 2, you should get 2 for your x value. I didn't see that little negative right there. Okay, so that's your x. X equals 2. Now for the y, you're going to have the same matrix for your denominator. And then instead of the negative 3 and negative 7, you're going to do 1 and negative 17. So we're going to have 5 times negative 17 here. So negative 85, and then minus 2, and then negative 35 plus 6. So that's going to give you negative 87 over negative 29, which is going to give you a 3 for your y value. And so that would be how you would solve using Cramer's rule. Okay, so these are questions that you know how to solve using substitution or elimination. But again, we're starting with little equations so that we can one day maybe do it to an equation that has 3 variables and we have a set of 3 equations. So a system of 3 Okay, let's look at one more. We want to use Kramer's rule to solve this. So to do our x, we're going to have 3, 3, 2, 2. And instead of the 3, 3, we're going to do 8 and 5, and then 2 and 2. So I'm going to have 16 minus 10, and then 6 minus 6, and I get 6 over 0. You can't divide by 0. That does not exist. Why did I get a 0? Any ideas? Okay, well the reason is because these lines are parallel. You see how the x and the y part are the exact same, and you just have a different number here, 8 and 5. Those are your y-intercepts. So you have parallel lines. When you're looking for a solution to a system of equations, you're looking for where they intersect. Do those parallel lines ever intersect? No. So that's why we got it does not exist, because those are actually parallel lines. So whenever the determinant of the coefficients of a system of linear equations has a value of 0, the system does not have a unique solution. So whenever you get your denominator equals 0, you do not have a unique solution. So this one you would just have no solution. Okay? So if your denominator equals 0, that means that you don't have a unique solution there. Okay? So make sure that you do your homework tonight, 1 through 30, so that we can go over any questions that you have tomorrow.